Welcome back, everybody. This is going to be our Algebra 2 Essentials, Lesson 6, Using Tables on the Calculator Homework Review, Part 3. And this will be the last part of our Algebra Essentials, and we're moving on to our functions for next lesson. So hopefully this is helpful because it seems in this case we're doing a lot of basic stuff, but I want to make sure we know how to use a graphing calculator because it is a useful tool for us. Not only do we pay quite a bit for it, but also for the fact that it's got a lot of things that will help us progress a little further. So getting to know how to use it is pretty important though. All right, so for question number 6, the product of three binomials is shown. Write this product as a polynomial in standard form, where the highest power will be x cubed. So in this case, we're looking for as a single polynomial, but in this case, with x cubed being the highest one. So let us first do in this case example of our distribute method. So let's distribute here x times x. So x times x. We'll take the first two in this case. So x times 2. So we have x times 2. Then we'll have negative 1 times x. And then we'll have negative 1 times 2. And so here we combine everything together. We're going to get x squared, well, I'll put this here, x squared, 2x, negative 1x, and negative 2. And the like terms are going to be these two terms here. So 2x plus negative 1x is going to be plus 1x minus 2. And this is the trinomial we have for the first two. Now, if we continue, we're going to now use the area array method, or in this case, I refer to as the box method. And so it'll be a 2 by 3, and the 2 will be the x minus 4. And we're going to multiply by the trinomial we found, x squared plus 1x minus 2. And so now we're multiplying x times x, which is going to be x times x squared is x to the third. And we'll have, in this case, x times 1x, and so that'd be x squared, 1x squared, and then we'll have, in this case, x times negative 2, and that'll be negative 2x. Now we're going to multiply, in this case, negative 4 times x squared. We're going to have negative 4x squared. We're going to multiply, in this case, negative 4 times 1x, and we'll get negative 4x. And then we'll multiply negative 4 times negative 2, and we'll get positive 8. Okay, so here we'll see that the like terms are going to be diagonal to each other, so not always, but it works out this way. Here we have our x squareds and our x terms together. So now we get x cubed. Now 1 plus negative 4 will be negative 3x squared. And then negative 2 plus negative 4 is negative 6x plus 8. And so this is going to be our polynomial, or in this case quadnomial, x cubed minus 3x squared minus 6x plus 8. This is referred to as a descending order. Descending order of a polynomial is where they'll have the highest exponent first, then the next highest, finally written down to the constant. And so this is really the standard form of a polynomial, normally in descending form. Okay, so this is question number 6. Now, for question number 6, we really is important for us because, and I'm actually gonna do this here. I'm gonna highlight this. And I'm going to copy it because we'll see, ladies and gentlemen, that in question 7, set up a table for the answer you found in number 6 on interval from negative 5 to 5. So here I'm going to just put this back here, paste it, and I'll put it to the side here. And we're going to create a table, in this case, found in the 6 from negative 5 to 5, where does expression have zeros? So we'll break out our calculator. Okay, oops, let me just clear this. And so now we're going to set up our calculator y equals. Let me clear these previous entries from before. All right, so our entry will be x cubed. So it'll be x raised to the third power. Now we have to remember to move to the right. Then minus 3x squared, minus 3x squared, and then minus 6x plus 8. Okay, and so now we're going to look at a table. And so we'll set our table now. We're looking for the values from -5 to 5. So here's 5. And now it's automatically set up so we can just, in this case, -5 to 5. And notice how we have all the values here in our graphing calculator. A lot of newer ones will basically be able to have this large table. The older ones, TI-84s, may not have all of them, but you can scroll through them in the case. And so we're looking for zeros, okay? And so a 0 will be where we see the y value equals 0. And we'll notice in this case that when y is equal to -2, or x equals -2, or y is 0. Also when x equals 1, or y is 0 as well. Okay, and so in that interval from -5 to 5, we will have two zeros, -2 and 1. So in this case, x equals -2 and x equals 1. Just to make sure, post it again. -2 and 1. So those are zeros. Now, we can check this out just to make sure. We can we'll use our graphing calculator again. And even though we have a table, just to make sure, let's quit this and we're going to enter -2 in our store function, store for x. And then we're going to type in the enter. Okay, and so now we'll type in again, x raised to the third to the right, minus 3x squared, minus 6x, plus 8. Okay, and then we're going to hit enter, and we get a 0. We said the other x value, or the other 0 would be when x equals 1. So let's try a 1 now, just to make sure. And so we'll do 1, store, x, enter. And we're going to bring the calculator up to the original expression. We're going to enter and paste it onto here again, and hit enter again because now 1 is stored for x, not -2, and we also get a 0 as well. So we can look here and verify using a store and plugging into our expression. We can look at our table from -5 to 5 and notice that we will see that there is a 0. Okay, 0 and 0. Oh wait, there's another one. X equals 4. There's a third one. Okay, almost missed that. So x equals 4. And we'll check on our calculator one more time. And so here in this case, let's go with our home screen. And now we're going to store 4, store x, enter. And we're going to bring this cursor up to the expression again, enter. And now enter again, and we have the third 0. So we have to see there are 3 zeros. There are 3 zeros, or in this case, our roots. Now, one of the things we should also associate our zeros are where basically a 0 is where the graph was going to cross the x-axis. So a 0, ooh, font's kind of big. Let me see if I can change this font to a little smaller. So a 0. Okay, of a polynomial is where the graph crosses the x-axis. Now, the great thing about the graphing calculator, because it actually graphs as well if we're using graphing calculator. So we have this already set up for us. Let's take a look. So we have y equals expression. We're going to graph. And we see, well, that was really quick. Notice where the graph crosses the x-axis at x equals -2, x equals 1, and x equals 4. All right, and so 3 places, 3 roots. Okay, so this 0 polynomial is where the graph crosses that. Oh, sorry, I went that took away pretty quickly. So you guys can take a look again. Notice it's almost like an N shape, goes up and then down and up again. Okay, so this is kind of a hallmark of a cubic function, and we can talk about that a little more as we continue on with our lessons with in Algebra 2. So in this case, we see that we set a table. We can identify from the table the zeros where the graph crosses the x-axis. Now, let you guys know, we set our calculator to use integers and worked out nicely in this case that the graph crosses the x-axis at those values. And it's not Actually, to be honest, it's not a coincidence. Let's take a look at the original question here. Okay, the expressions were x minus 1, x plus 2, and x minus 4. If we set this equal to 0, okay, so oops, if we set x minus 1, x plus 2, and x minus 4 equal to 0, we will find in this case that we can set each of these. Remember we talked about the multiplication property of 0, that anything times 0 goes 0. So we know the whole thing goes 0. One of these has to be at least equal to 0. And so we add 1 to here, x equals 1, which is going to be the value we found. Subtract 2, x equals -2. Add 4, x equals 4. So here we see these are our zeros because, again, where the expression is equal to 0, well, because our factored force is factors, those three things, when any one of them is equal to 0, the whole thing equals 0. So here are three possible values of x that would make the expression equal to 0, and it corresponds to our graph. So the great thing about the graphing calculator is that we can take some of the ideas we have from an algebra point of view, just pure algebra, and then be able to use the graphing element, be able to connect the concept of an algebraic kind of an algorithm type of way or equation situation, and see how it comes out from a picture point of view. So they should both work out synchronous, meaning give us the same results in this case. So hopefully this was helpful and being able to use a graphing calculator and noticing in this case we found zeros and they kind of match up to the ones that we found on our table. All right, so there's a lot of ways to help us find values. We'll explore a little more on our using the graphing calculator when finding more zeros or roots. Another word for zeros or root as well. Okay. Please leave any questions or comments and feedback for this video. We'd love to hear feedback from you guys in the comments section below. And if you found this video helpful, please leave it a like. I hope you guys are watching these things. I mean, I do them for you guys, and you know what? I'll keep doing them, whether it's one person or 1,000 individuals watching this. If it helps you guys understand the material, then it's a great thing in my mind. And so, yeah. Now, keep watching videos. The next one's going to be working on functions, and we're working on those as we develop our learning, our knowledge of Algebra 2. Thanks so much for watching, and as always, be safe. Take care.